AI coding tools are improving every day. They can write code, debug complex systems, and generate entire architectures in minutes. But here is the thing. You spend 20 minutes explaining your project to an AI. You get a great answer, you close that chat, and the next day you have to start all over again, inputting the exact same context again when using different AI tools. Or maybe one conversation knows your brand colors, another one knows your product architecture, and a third tool knows absolutely nothing about either of them. The model can be brilliant, but it has no memory. Your knowledge is still scattered across chat histories, random folders, and old notes. So, what if your AI tools could share one organized, persistent knowledge base? What if this knowledge base were portable and could be shared seamlessly across different AI tools? That is exactly what we are going to build today. This is called the LLM Wiki. Hello, welcome back to the Ninja Robotics Education channel. We aim to break tech barriers so anyone can build, create, and innovate. In this video, I will show you what an LLM Wiki is and how it can supercharge your AI tool experience. Moreover, I will share an LLM Wiki template with you so that you can easily integrate it with your own AI tools. So, without further ado, let's get started. This video is sponsored by HP Auto and Fish Republic KK.
この番組はご覧のスポンサーの提供でお送りします。
First of all, what exactly is an LLM Wiki? A couple of months ago, Andrew Karpathy, one of the big names in AI, co-founder of OpenAI and former director of AI at Tesla, shared the concept of the LLM Wiki. It's an idea for building long-term memory for AI agents, so they can remember information and use it reliably to answer questions. The basic idea is simple but powerful. AI models were trained on data from the public internet, not your local project data. They don't know your specific setup or private documents. So we need to build and provide a long-term knowledge base for them. Think of it as an external memory bank for your AI tools. You may have heard of RAG, or Retrieval Augmented Generation. In RAG, you upload some files, you ask a question, the AI searches through those files, retrieves relevant chunks from a vector database, and generates an answer based on that information. That works fine for simple questions. However, there is no persistent structured memory. The AI has to redo the repetitive retrieval work every single time. Not to mention the complexity of setting up and maintaining a vector database. An LLM Wiki focuses on a different layer entirely. The knowledge is written into standard Markdown files. Markdown file is a simple text format designed for clean formatting and easy reading. Every wiki page contains a small metadata block at the top. This records details like the page type, title, description, status, and sources. This metadata block is called YAML from the matter. This is just a few lines of structured data between triple dashes. That describes what the Markdown file is about. Below the metadata is the actual article, written in natural language. It includes citations, so the AI can always trace claims back to registered sources. That gives us something a normal chat history does not provide, an organized, inspectable, and verified record of knowledge. Our LLM Wiki template also follows Google's Open Knowledge Format, or OKF in short. Google published this as an open standard inspired by Andrew Karpathy's LLM Wiki concept. OKF is essentially a set of simple rules for representing knowledge in files. It standardizes the content format so that your knowledge is truly portable across different AI tools. Okay, let me show you a real example so you can see what the end result looks like. This is the LLM Wiki template I built for our Ninja robotic education platform. The original information came from project documentation, development notes, design guidelines, and UI/UX visual brand posts. As a platform grows, documents quickly become messy and harder to keep organized. That's why we need an LLM wiki. So every developer and AI agent can share the exact same knowledge base and work synchronously. Right now, this example contains 15 registered sources. 7 of those are images, including screenshots, color references, brand guides, and a complete user flow diagram. The agent used those sources to build 28 interconnected wiki pages. If you install Obsidian, which is a powerful Markdown node-taking tool, you can view this graph view that looks like a spider web. Each node represents one page, and links connect them to show their relationships. This graph view gives you a complete high-level picture of your entire knowledge base. In our knowledge base, the pages are divided into simple groups. First, concepts explains core ideas and systems. Entities describe specific products, services, or organizations. And references represents the raw source evidence used by the wiki. Now, here is the really satisfying part. I originally built this knowledge base using OpenAI Codex. Now, let's open it in Google Antigravity and ask a practical question. Something like, please tell me the brand color system of the Ninja Robotics education platform. You can see the agent searches the local wiki following the workflow we provided in the agent skills. It finds the brand and design system pages and the brand color system. From the wiki, it accurately tells us that the platform's primary brand blue is 0099FF, and the dark navy is 07111C. And here is the important part. The AI answered by retrieving the exact local wiki pages. No hallucinations, just your own verified knowledge. Every registered source has a content hash as a digital fingerprint for the document. If the source file changes, its fingerprint also changes, and the wiki can detect that the page may need attention. Now that you have seen the result, let's dive into the workflow behind it. The LLM wiki system has 3 main functions. First, ingesting local source content. Second, retrieving knowledge to answer questions. And third, in linting the wiki to maintain its quality and health. First, ingest the local content. Everything starts in the raw folder. This is where your original evidence lives. There are 4 main places for source files. First, articles is for finished documents, like manuals, guides, reports, or saved web articles. Papers is for research papers, technical white papers, standards, and specifications. Notes is for less formal material, something like meeting notes, brainstorming notes, development logs, or your own working sketchpad. And media is for image files, including PNG and JPG files. The folder structure mainly helps us stay organized. For supported text documents, putting a file in articles instead of notes will not change how the text is processed. Images are the exception. Supported images should always stay under the media folder. The template currently supports Markdown, plain text, HTML web pages, PDF documents with selectable text, and PNG or JPG images. When a source is added, we can run AI tools to ingest it into the local catalog. The source receives a stable unique ID and a content hash. Next, the source is converted into a clean, predictable format that the workflow can safely process. For the text document, this means extracting clean, normalized text. For an image, it uses OCR. OCR stands for optical character recognition. It extracts visible words from an image. However, basic OCR is not the same as truly understanding an image. If the visual content matters, you should inspect the image and provide detailed context in the wiki manually. The second function is retrieval. When you ask a question, the agent searches the Markdown pages for matching topics. It opens the strongest results, follows related links, checks page status, and inspects source records. Then it generates an answer backed by the local wiki evidence. If the wiki does not contain enough information, the agent is instructed to clearly state what is missing. It will not quietly guess from its general training data or pretend that the information came from your wiki. This workflow is also completely tool independent, and that is really important. For example, you can use OpenAI Codex to ingest the new content and then open the exact same folder in Claude Code or Antigravity to ask questions. Just one practical rule to keep in mind: avoid having two AI tools write to the wiki at the same time. Third, link the wiki. The third function is linting. If you have ever used a code linter, it's the exact same idea applied to your knowledge base. A linter is a tool that checks files for common errors and structural issues. Here, the linter checks the health of your wiki. It verifies page structure, required YAML metadata, internal links, citations, and generated indexes. It reports linting finding in 3 tiers. First, errors means something is broken and must be fixed. Warning means the wiki will still work, but something deserves attention. Suggestions are review cues to help improve quality or style. You can run this simply by prompting your AI tool, lint my wiki. After linting, you can ask your AI tool to review the flagged issues and fix them automatically. This drastically reduces manual workload, prevents confusion, and eliminates broken links. But here is an important note. A linter can verify structure and recorded evidence, but it cannot guarantee real-world objective truth. As we always say, garbage in, garbage out, the ultimate quality of the wiki still depends on the quality of your sources and careful human review. Now let's build a new wiki from the blank template. Before you begin, make sure Git, UV, and OpenAI Codex are installed on your computer. You can find the wiki template GitHub link in the video description below. Open the GitHub repository link in the description. Click the code button and download the project as a zip file. Extract the folder, then rename it for the topic you want to build. For example, I will call it my personal wiki. Before we ingest anything, we should initialize Git. Git is a version control tool. It saves the history of your files, so you can inspect changes and roll back to any earlier version if needed. Run the following command to initiate Git. The template does not push your content to the internet. It can remain completely local unless you intentionally connect it to a remote repository. Next, we install the project dependencies with UV. UV is a blazing fast tool for managing Python and the packages used by this project. Run following command, then initialize and inspect the wiki by running the following commands. The first run should pass cleanly because the template starts as a blank canvas. At this point, the wiki is ready to go. Now, choose a Markdown file that you want your wiki to learn from. In this case, I will use my personal resume. I will add my resume Markdown document into the law/articles folder. Now simply open the AI Codex CLI in the root of the project. Because we launched it from inside this project folder, Codex automatically discovers the project's instructions and the skills stored under .agents/skills folder. So we can simply prompt the Codex with something like, I have added new sources under the low folder. Discover the unregistered files, register and ingest them into my wiki. Now watch what happens behind the scenes. Codex now first run the project health check, then it identifies the new source. Because this is a blank wiki, it will propose a new concept or reference page. The agent then creates a change plan for your approval. If that plan looks good, tell Codex, I reviewed the plan and approve it. Then Codex applies the change, updates the wiki, reviews the generated index, and runs lint. Your first topic is now part of the local knowledge base. Now you can ask the agent questions about your personal background, something like, what university did I graduate from? And just like that, it acts as your personal assistant managing your verified information. This can be incredibly useful for interview preparation and portfolio management. And that's how you build your own local LLM wiki. You can now turn it into a well-organized library of reliable, linked, and source traceable documents. The best part is that this is a fully scalable system. There are so many ways you can use it. You could build an internal product wiki from company documentation, including meeting notes, product requirement documents, design rules, and maintenance guides. Moreover, for privacy-sensitive content, you can integrate this wiki into any private agent workflow, running completely local AI models. The template never locks you into one AI provider. AI tools may come and go, but your knowledge remains stored in open, human-readable files that you fully own and control. If you found this video helpful, please hit the subscribe button and drop a like. That means a lot to me and helps me continue creating practical AI projects like this. Thanks for watching, and I will see you in the next video.